Hello, welcome to a rare virtual lesson for this year. We are in the last section of Chapter 4. We have found several different ways of solving quadratic equations. We've graphed, we have factored, we've used the square root property, and we've even completed the square. I almost forgot about that one. And this is going to be our last method of solving quadratic equations. The quadratic formula. Why is the quadratic formula useful and what is it? Well, it's useful because no matter what quadratic equation you have, you can always use the quadratic formula to solve it. The only other method that we've learned about that will always work is completing the square. And it depends on the person, but it's not the easiest method of solving quadratics, in my opinion. Quadratic formula, probably a little simpler. So it's the simplest method we're going to learn that will always work. What is the quadratic formula? Well, we'll get to that in a minute. But in your notes that you can see here, I've got some warm-up questions. I've got 4 of them. We've got 4 quadratic equations here, and we've got 4 methods that you can use to solve that we've talked about. So what I want you to do, pause the video for just a minute and see if you can match up which method would work best for each of those quadratic equations. You've got multiple options, but which method would be best, would be most efficient, the quickest way to get the solutions? Pause the video, take a look, and we'll talk about it in a second. Okay. Have you matched up each equation with a method of solving? Let's take a look. First one here, x squared minus 6x plus 9 equals 16. What I notice here, the first and last terms of the expression on the left are perfect squares. And as a bonus, so is the term on the right. I think we should be able to use the square root property here pretty well. This is going to be x minus 3 quantities squared equals 16. Take the square root of both sides. Even this side ends up being something nice. So I think square root property is best here. That is letter D, as in dog. Okay. For the second one, x squared plus 2x equals 7. Remember, when completing the square, what we need is x squared plus bx. The form this is in lends itself perfectly to completing the square. You've already got what you need on this left side. You would take b over 2 quantity squared, that's going to be 1. Add that to both sides. Write this as x plus 1 squared equals 8, and you're off to the races. So I think, completing the square, letter A, might be best the way that one is. Third one here, x squared minus 7x plus 12 equals 0. I think that's just good old-fashioned factoring. Look for 2 numbers that add to negative 7 and multiply to 12. Let's see, that would be 3 and 4. Negative 3 and negative 4. Took me a little bit. I haven't actually done these examples. But your 2 numbers are negative 3 and negative 4. So this factors into x minus 3 times x minus 4 equals 0. Set your factors equal to 0 and solve. So this is regular factoring, B. And the last one here, x squared minus 1 equals 0. You've got options here. I think this one would be pretty easy to factor as well because this is a difference of squares, right? This would factor into x plus 1 times x minus 1 equals 0. Set each equal to 0 and solve. But since we already used factoring here, by process of elimination, this one might be good for graphing. Okay? Because, among other things, the solutions are going to be integers. I also think it's easy to factor as a difference of squares, but for the purposes of this exercise, I think this one's good for graphing. So the point here is, you now have many tools in your tool bag for solving quadratic equations. What you might want to consider is, the method you use may be dependent upon what the quadratic equation looks like. If you've got perfect squares in the front and back, check out the square root property, see if it works with that middle term. If you've got something in this form, that's completing the square. If something can be easily factored, go ahead and do it. Factoring doesn't always work though. And, graphing is always possible, but I don't subscribe to using graphing very often for these. Okay? But we're going to learn a brand new method here that I think is simpler than completing the square and always works, unlike some of these methods. The quadratic formula. Here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What? Apparently, if you've got a quadratic equation in standard form, which is this, and say you set it equal to 0, if you know the values of a, b, and c for a quadratic equation, you can just plug those values into the quadratic formula and get your solutions for what x is equal to. That's kind of magical, I think, right? Like, all we have to do is plug numbers into that weird-looking formula. I don't know, maybe it's just me. I kind of want to know, where does it come from? How does this work? It's not just magic. There's a reason. And I think, based on what we've learned so far, we have all the tools we need to find out where that formula comes from. Let's take this standard form of a quadratic equation and see if we can get the x by itself. That should give us this. We're going to need to complete the square to do this. So, what we need is x squared plus bx. So 2 things need to happen from the very beginning. 1, the c needs to move to the right side, and we're going to need to divide by a everywhere. Let's go ahead and divide everything by a first on both sides. This is a valid mathematical move because we're doing the same thing to both sides, dividing by a. This is going to give us x squared plus b over a x plus c over a, and we still have 0 over there. Okay. Mr. C, why would you do that? Now you've got fractions everywhere. Well, you remember when we completed the square before. Sometimes there are fractions involved. This is no different. Okay. We're going to need to move now the c over a to the other side. So we're just going to subtract it from both sides. So we have this. Now, we've got on the left side here what we need to complete the square. So we can find c. Don't confuse this c with the c we've been working with here. This is just the value that we need to complete the square. Okay? This is equal to this quantity over 2 squared. This is the same thing as this. This is going to be b squared over 4a squared. This might start looking kind of like what we need to get in here somewhere. Okay, this is the value that will complete the square, so we need to add this to both sides of the equation that we have. I'm going to do that over here. So we've got x squared plus b over a times x plus the value that completes the square equals, we had negative c over a plus our value that completes the square again. So we have this. Sorry, it's a little blurry over here. This is b squared over 4a squared here, this value. So this looks like a lot bigger of a mess than what we started with, but we've completed the square over here. We should be able to write this as something squared. And in fact, this is x plus b over 2a squared. And on the right side, maybe we should get a common denominator here of 4a squared. So we need to multiply this on top and bottom by 4a. So that's going to give us b squared minus 4ac all over 4a squared. Okay? We're getting close. We completed the square here, so now square root property. Let's take the square root of both sides. Again, we're trying to get the x by itself. So we take the square root of both sides. That gives us x plus b over 2a equals. We can take the square root of the top and bottom separately here. So the square root of the top, let's just keep that as the square root of b squared minus 4ac. And on the bottom, the square root of 4a squared is 2a. Only one more step left. Subtract b over 2a from both sides. Oh my gosh. I almost forgot something. There was no one here to remind me. Not my baby, not my cat. How could I possibly forget? When we do the square root property, and I know you're screaming this at your screen right now. I forgot. My plus minus here. Oh my gosh. Oh, jeez. Have I mentioned my baby hasn't been sleeping recently? Never mind. Let's subtract b over 2a from both sides. So we've got negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Since we've got the same denominator of both terms here, 2a, let's just write it as a single fraction. X equals negative b plus or minus b squared minus 4ac all over 2a. The quadratic formula. That's where it comes from. Okay? We start with a quadratic equation in standard form. We complete the square and solve for x. That's why it works. These are the values of x that set our quadratic equation equal to 0. They are the solutions. So that's how it works. Do you need to be able to derive the quadratic formula like this for a quiz or a test? No. But hopefully it satisfies some curiosities and it helps give you confidence that you can use this formula and it will always work. No matter what the values of a, b, and c are, plug them in here, they will give you the solutions. Let's see how it works with an example, shall we? All right, let's use the quadratic formula to solve a quadratic equation. And let's make the example interesting for our first one here. So there is this thing called pumpkin chunkin', and if you don't know what that is, pause this video and go look it up. Look at some YouTube videos of pumpkin chunkin'. There are some very talented engineers out there who can create devices that fling, shoot, and I don't even know what other verbs to use, pumpkins very far. Long, long distances. I think you can use a giant air cannon to fling a pumpkin nearly a mile in the air. Like not vertically, but like horizontally. Like, phew. It's crazy. Go look it up. Go. Go look it up. Come back when you're done. Isn't that crazy? Okay, now that you know what pumpkin chunkin' is, because I know you paused the video and did that, right? Okay. Let's see what we've got here. The path of a pumpkin can be modeled by this equation. We've got h equals negative 16t squared plus 124.5 0.4t plus 42. H is the height of the pumpkin, and t is the number of seconds after launch. Okay, and we want to use the quadratic formula to solve the equation and interpret the roots. Okay, so let's use the quadratic formula here. This. In order to use this, we need to know the values of a, b, and c. So anytime that I'm using the quadratic formula to solve a quadratic equation, the first thing I do is write the values of a, b, and c. I think this is a very good idea. A is the value in front of, usually it's x squared, but here for this equation, our variable is t. So A is negative 16. B is the value in front of t. That's 124.4. And C is the constant at the end. That's our 42. So, solving this equation using any of the other methods that we know about would either be impossible or very difficult. I don't think this is factorable. Not that I've tried, but I don't think it is. I suppose you could graph it, but that's kind of cheating. Square root property. Ooh, this is actually a perfect square, but 42 isn't. And you could complete the square here, but let's not. I would much prefer, especially since I know the values of all these variables, just plug them into this formula. I think that's a good alternative. So let's plug them all in. X equals negative b plus or minus square root of b squared minus 4. This is always going to be a 4 in here, no matter what, times a times c, all over 2 times a. Okay, couple things here. Be careful when you're plugging these numbers in. If any of these values are negative, make absolutely sure that you reflect that when you plug it in. Right? Inside here, when you're doing 4 times a times c, I would highly recommend plugging these in parentheses to help you notice this is going to be negative 4 times negative 16 times 42. That's all multiplied together. And then also down here, 2 times a. If you don't put that in parentheses, you might end up thinking that's 2 minus 16. You don't want to do that. This is multiplication. Okay. So, what I recommend here, type this into your calculator. Not all at once. I would not do this all at once. I would do it in pieces. I would figure out everything inside the square root first. Okay, leave everything else for now. Okay, find out what's inside the square root. If you want to pause the video and figure it out for yourself, I would highly recommend that. You get better by practicing on your own. Unpause the video when you're ready to see what number you should end up with in here. I get 18,163.36. If I were doing this, I might even, before I even get to this step, figure out what 124.4 squared is, write that down, minus, and then multiply these 3 numbers together and write that down inside. So this might actually be the next step down. But hopefully that's enough detail. You know where that comes from. All of this is going to be over negative 32. Okay. So you'll notice I've turned this into a decimal. You know I'm usually a fraction kind of guy. I felt justified because b was already a decimal here. Okay. If it starts out with decimals, you have my permission to keep it as a decimal. Just don't round until you absolutely have to. That would be like at the very end. Okay. So we have this. This is actually two numbers. Okay. So let's write both of them. So we've got x equals negative 124.4 minus this big number in here, all over negative 32. And then we've got the positive version. Okay. Writing both solutions like this is very helpful because if it's correct, then it's correct. However, since these are all just numbers, I would prefer that you actually evaluate what these are. Okay, so x is approximately, for this first one with the minus sign, this is approximately negative 0.32. And this one with the plus should give you around 8.1. Okay. So, we've done almost everything the problem has asked, but this is how to use the quadratic formula. Right? If you've got a quadratic equation in standard form, which this already was, ax squared plus bx plus c, write out what a, b, and c are, plug all your numbers into your formula, be careful as you simplify it, okay? Write out both of your solutions, and then evaluate them. For this problem, though, we have context. This is a story problem, right? We're chunking pumpkins here. So we are supposed to interpret the roots. And in order to do that, we should probably figure out what the units are. I'm calling this x. That's just an old habit, right? We usually use x for our variable here, but here it's t. So maybe you've been yelling at me this whole time. Mr. C, it's t! And you're right, it is t. Leave it to when I make a video and post it on YouTube for the world to see that I messed that up. So these are all t's. T, 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 t. Have I mentioned my son? Never mind. T is in what units? Going back to the problem here, t is the number of seconds after launch. This is seconds. So the path of a pumpkin can be modeled by this equation. H is the height in feet, and t is the number of seconds after launch. So this root would suggest 0.32 seconds before the launch. It was at a height of 0. That's not really what we're interested in. We want to know how many seconds after launch. So this is the only solution or root that makes sense in this context. So what this represents is it takes 8.1 seconds for the pumpkin to hit the ground. After launch. That's a long time. Okay. If you think about this original quadratic, what it might look like on a graph, notice A is negative, so it opens down. So you can kind of see, maybe it starts here, gets launched in the air, hits a peak, comes down, hits the ground. And it takes 8.1 seconds to do that. We're going to do one more example using the quadratic formula to solve a quadratic equation in this video. It's example 2 in the notes. If you want to try it, it's simpler. There's no context, there's no interpreting the roots, just straight up using the quadratic formula. If you want to try that, go ahead, pause the video now before I get started on it, and we'll see if we end up in the same place. All right, let's do another example of using the quadratic formula. As we start this one, a reminder, you can only use the quadratic formula if you're dealing with a quadratic equation in standard form, ax squared plus bx plus c equals 0. If it's in any other form and you want to use the quadratic formula to solve, you have to get it in standard form first. You'll see in the notes here, all of the examples, they're given to you in the correct form already. But know that you can put it in this form if it's not already to use the quadratic formula. So let's go for it. Here we go. First thing, once it's in standard form, write the values of a, b, and c. Right. A is 1. B is negative 34. Okay. Careful again with those negatives. They do always go with the number after them. And C is 289. My guess is this isn't factorable. Maybe it is. Oh my gosh. You could factor those. But the directions say to solve using the quadratic formula. So that's what we're going to do. It's a nice go-to. I can't believe it. It is factorable. Anyway, let's use the quadratic formula anyway. We've got x equals, and thank goodness we're back to using x so I can not get in trouble here. Negative b, so that is negative 34. Okay, this is a very common mistake I see when students use the quadratic formula. If b is negative, there are two negatives out here. A common mistake is people just write negative 34 without thinking, oh, it's negative 34 and the formula has a negative sign in front of b. This will end up being positive. You'll see that if you write it this way. Plus or minus square root of b squared minus 4ac. All over 2 times a. A is just 1 here, so that should be a lot easier to work with. Okay, so from here, we've got positive 34 plus or minus the square root of 34 squared minus 4 times 289. This is my calculator. Beep, beep, boop, 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 boop. Oh, okay. Turns out, if you don't want it spoiled, pause the video. This is your last chance. $34 squared and 4 times 289 are the same. So when you take the difference of those two things, you get 0 inside the square root. Fun. This is all over 2 times 1, which is 2. So that makes our lives pretty easy. The square root of 0 is just 0. So this is 34 plus or minus 0 over 2. But 34 minus 0 and 34 plus 0 are both just 34. So really, there's only one solution here. X is 34 over 2. Which is 17. There's only one solution to this quadratic equation. I wonder why. Huh. By the way, I said you could factor this. In fact, it's a perfect square trinomial. 289 is 17 squared. So you could have written this side as x minus 17, quantity squared, equals 0. Take the square root of both sides, add 17, and you would have gotten this. But now you know you can also use the quadratic formula. You can't always factor, but you can always use the quadratic formula to get your solutions. So we've now seen 2 examples of using the quadratic formula. For the first one, we got 2 solutions that were irrational, right? They had the square root of a decimal as part of the solution. Then we saw this one where there's just one real solution that also happens to be a rational number. There are other things that can happen when you use the quadratic formula. If you've got a copy of these notes here, ding, 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 go ahead and look at some of the questions on the back side. New equations, use the quadratic formula, see what kind of solutions you get. In tomorrow's video, which is going to be the back side of these notes, we're going to talk about all the different things that can happen in terms of your solutions when you use the quadratic formula and why that happens. We'll also talk about what's called the discriminant and how that plays into it. So, for now, I think we're good for today. Tomorrow, make sure you check out part 2 of this video and find out how it all fits together. We'll see you then. A little bonus for those who made it to the end of the video, here's my little boy. This is Alexander, and he is shy to be on camera. It's over there, buddy. Where's my little man? There he is. Whoa. Daddy's doing math. Say goodbye, everybody. Bye. We'll see you next time.